Let's go ahead and take a look at sort colors, LeetCode 75. We will start by looking at the problem statement. I'll mention two approaches, a slower solution and a more optimized solution using the two-pointer approach. The two-pointer approach is for sure the solution you should be using in any type of LeetCode-based interview problem. It'll give you a lot more points. And as always, thanks for grokking, and remember, we're here to learn and not memorize. So looking at the actual problem statement, let's highlight some key things. We know we're going to get an array of numbers. However, that array correlates to these colors, red, white, and blue. We have to sort them in place, so no extra data structures. And then we learn on the second line, even though they mention these colors, these are integers. 0 corresponds to red, 1 corresponds to white, 2 corresponds to blue. And this can be confusing. And honestly, I would just recommend don't even think about the colors. Ultimately, we're just sorting a list. 0 has to be on the left-hand side, 2 on the right-hand side, 1 is in the middle. So it should just be 0, 1, 2. And then we have another big key component. We cannot use the library's built-in sort function. And this was the first naive approach I mentioned up top, that this problem could easily be called if you just do nums.sort, return that. Python's built-in sort method is very quick. It does run in n log n time, which is not bad. However, using the two-pointer approach, we can solve this in n time, which is a lot better than doing .sort. And we don't have any extra memory. We're doing it in place. It does everything. So to talk about the problem a bit more, we're ultimately going to have three ways to keep track of systems. We're going to have an I variable. That's what we're going to be used to looping. Then we're going to have a left pointer, which will be on the left-hand side. So this is where all the lower values should be. So everything on the left-hand side should be lower than everything on the right-hand side. And having said that, we'll have a right-hand pointer, where everything on the right-hand side has to be bigger than everything on the left-hand side. Now we have three conditions we need to deal with. If I is equal to 0, we have to do something. If I is equal to 1, we do something. And if I is equal to 2, we do something. So if we look at our initial example given to us here, I starts off as 2. So it's like, oh, 2 has to be on the right-hand side. So we go ahead and swap it on the right-hand side with our R pointer. So now we have 0, 0, 2, 2. Oh no, second 2 doesn't come in. 1, 1, 2. Great. So now we increment our left and right hand pointers. We see a 0. They're like, hey, this is what we want. So let's just go ahead and increment our I pointer. So now we're looking at this 2 over here. We see a 2. We're like, oh, it should be on the right hand side. We decremented our right pointer because we already made one swap. So we're going to go ahead and change this over here. So now we have 0, 0, 1, 1, 2, 2. And then we keep cycling through. We see the list is already ordered, and we could go ahead and return. Now with that, let's go ahead and jump in some code. Okay, looking at some actual code now. And as always, I have a solution summary up here at the top. I also have a key here I want to call out, because even though the problem statement does say we want to sort colors, really we're sorting integers. So just to make it easy, 0 is equal to red, which is going to be equal to our left-hand pointer. 1 is equal to white, which is our looping variable index, I. And then 2 is equal to blue, which is our right-hand pointer or the end of our list. And then I have the actual algorithm we're going to be using written out. That way you can pause, see the summary, and look at the code. The basic idea is we have three cases we need to deal with. If the element I is equal to 0, then we want to swap with left to make sure zeros are always on the left-hand side. If the element is equal to 1, all we want to do is increment I, because presumably we're in the middle, and 1's supposed to be in the middle, so let's just move forward. If the element is equal to 2, then we want to swap with right, because everything on the right-hand side should be higher, specifically should be 2. And then finally, we just sorted our array. Let's go ahead and return. So up top, we know we need three different variables. So let's do left is equal to 0. We have right, which is going to be the end of our list, colors -1. And then I, our looping variable. And the reason specifically I do I instead of, we're going to be using that in a while loop. So that's going to be our conditional. So while I is less than or equal to our right pointer. So now we're looking at as long as I is less than right is going to be coming down as we look through, I is going to be up. At some point they're going to pass. That's when we know we sorted everything in place. So let's take a look at our actual conditions. So if colors at our ith index is equal to 0, then we want to swap everything on the left-hand side with I. And Python makes it very easy to swap things. We're going to do colors left, comma, colors I, a single equal sign, colors I, single comma, colors left. And just to explain this line to make sure we know what we're doing. So we see where we currently are in the loop is equal to 0, and we want to make sure we put all zeros on the left-hand side. So we're going to take the 0 and assign it to the left, and whichever at the left index, we're going to assign it to I, because we don't know, maybe it's a 0, which would work out conveniently, but maybe it's a 1, or even worse, maybe it's a 2, and then we have to move it to the right. But so far, we're only concerned with moving zeros to the left. Great, so we saw that. Now we have to update our pointers. So we're going to do left plus equal 1, and I plus equal 1, so we could check what's coming next. Now, the next thing we need to check if we're looking at 2. So now we want to do the same swap, but we want to put everything on the right-hand side. So we're going to do colors right, comma, colors I is equal to colors I, colors right. And same thing up above. Our I, where we currently are, if that's equal to 2, we want to make sure that's on the right-hand side. For putting that 2 value on the right, then whichever it might be, we're putting it, whichever was on the right, we're putting it at the ith index. And similar above, we have to change our index. So we want to move our right value down. Boom. And now we have our final case where if I is equal to 1. If it's just equal to 1, we can assume, hey, we're in the middle at some point. So let's just update I plus equal 1. And finally, we just want to return colors back to make sure it's actually sorted. So that's the actual algorithm. Really simple. And just like at the other videos in this series, relies on a while loop. We're comparing some type of index against the pointer. We make some type of operation, and then we update our pointers. Then if we look at our actual main, I went ahead and copied the actual LeetCode problem examples, and then added a whole bunch of other ones. So let's go ahead and run this and see how it works. So we see our output right here, an unsorted list. All the zeros are there, 1, 2, that's great. Start off with 2, 0, 1, 0, 1, 2. There's no 2 in this one, so but 0, 0, 1. We have a list of length 1, only 2s, sorted, that was easy, 0, 1, 1, 2, and then another sorted value. So it looks like the algorithm worked great. Thanks for watching. If you have any other suggestions, leave comments. You guys know how the internet works. Subscribe, like, whatever it might be. But thank you.